radical and rational equations. Radical equation is an equation that contains a radical, stating the obvious. Okay? Rational equation is an equation which at least one term is in rational expression. So that could be like a 2x plus 3x over an x or something. Just that one has to have a rational expression, and then that would qualify for a rational equation. Okay, so then review of zeros, roots, and x-intercepts. So this is just that thing that, again, Math 20 beats it down forever, but zeros, roots, and intercepts are the same thing. I'm not going to, all this is, if you want, zeros, the root, or x-intercepts, roots are the same. So whenever you see a term 0, root, or x-intercept, you expect that to be the same value. Okay, so that's, again, I've probably said that 20 times this year between the 3 classes. Okay, maybe more. Okay. So a little bit of application question here. So we have a physics one, it looks like. Ew, sorry. All right, so let's see what this was talking about. So in physics class, students were given a long piece of string and weight and asked to create a timing mechanism. Courtney knew that if they created a simple pendulum, the relationship between the length of the pendulum and the time it takes for the weight to swing back and forth can be approximated by the formula of T equals 0.2 radical length, where T is seconds and L is length in centimeters. She decided to create a simple pendulum with a period of 1 second. It would take 1 second to swing back and forth. Okay, write but do not solve a radical equation that we use to determine the length of the pendulum. So we know that her time's 1, so we know the equation would be 1 equals 0.2 square root L for given time. Explain how the length of such pendulum can be determined by using the x-intercept of the graph of the radical function. So what would that mean for the x-intercept? So if we minus the 1 over, so what it says is the graph would be, if we want to graph it, well, when we graph something, there's 2 things you can do, right? If we're being technical, we could put 1 into y1 and then that into y2, or if we're doing x-intercept, we want one side to equal what? 0. And so then if we want to graph it, our y1 could be 0.2 radical L minus 1. And then we could do the x-intercept method. Okay, both work, but that's basically what they're asking you. Okay, and then it wants you to solve. Okay, so it also wants us to sketch it, so I'm going to move down here in a second. This is pretty basic for how wordy it looks. It's not very difficult. So it wants us to sketch it. Okay, and the sketch would look something like this if you do the y1 we talked about. So if you put this into y1, you might have to make your x max a little bigger. But if you have the 0.2, it'd be square root x minus 1. That's what's in your calculator. It's going to start down here at -1, and then it's going to grow like this, like that, and this is the solution we want. Well, that solution is going to end up being 25. Okay, if you did the 0 function, your calculator could figure that out. You also could solve this. It's not a very hard question to solve, and I will do that real quick here on this side. And then we're going to talk about what these numbers mean, how they line up. Okay, so let's just solve algebraically too, just so that we're familiar. So if we left the 1 over here, okay, you divide 0.2 to 1. Okay, well, 0.2 goes into 1 5 times, okay, because it's 1/5. So 5 equals root x, and then we square, we get x equals 25 in this case. And that's what you'll get in the graph as well. Now what this means, okay, that for 1 second, the pendulum moves 25 centimeters. That's what it means. For 1 second of time, like what it's doing, okay, it moves, the distance is 25 centimeters. Okay, that's what it's saying. On the grid, determine the approximate length of pendulum with a period of 1 second. So the length of how far that thing's, you're going to essentially drop it from, okay, to keep that consistent swing is 25 centimeters. Okay, that's it for that question. Anything on that at all? Okay. All right. This is all we got here. Just a couple more examples. Partial graph of y equals f of x, a radical function with integral 0 is shown. Okay, state the 0 of the function. So it's telling you it's integral. So what's the 0? Yep, -2. State the root of the equation. Same question, right? They're doing that thing again. Root and 0. Use the graph to determine the nearest whole number, the solution for when f of x equals 3. And a lot of you guys need to work on this. Because a lot of you guys, when you were doing stuff with function notation in your midterm, were confusing what this is actually saying to you. And I want to just be direct with it. What this means is, when is the function 3? That's what it means. And when it says, when is the function 3, that means the outputs, that means you're looking at the which values? The y's. Yes. When is the function 3? So when does it output 3? Outputs are y's. Okay? You're looking for the answer of x, yes. But this is telling you y is what I meant. Okay, yeah, you're right. And you are looking for x, yes. Okay, so here's 3, right? So you're right here. That's what we want. 7. 7 is the solution for when that function is 3. And see, they just did one little thing to you. F of x minus 4 equals 0. Well, what are you going to do? F of x equals 4. So then you're going to go, where is it 4? 14. Okay, and that's it. Just reading the graphs for what it's asking in terms of outputs. Okay, any questions on this? I'm going to move the page up to do the work on D. So any questions? Okay, quiet Monday. Okay, so let's look at D here, and then we got one more example. Okay, so in each case, explain how to use the graph of f(x) to determine the approximate solution to the given equation and state the solution to the nearest whole number. So f of x plus 6 equals 0. Well, we know what that does. F of x plus 6 does what to the graph? Translates it left 6. So our solution was, what was our solution? -2, right? So if our solution was -2, we're going to minus 6 to that to get -8 for our new solution. So our solution was -2. I shifted it left 6, minus 6 to that solution for -8. Okay. F of x minus 3 equals 5. So now it also equals 5. We'd like it to equal 0. So let's write it like so we can see the move. Okay. So we can do it with 5 and do it to the point, or you could leave it at 5 actually, technically. Actually, I'm going to leave it at 5. I got ahead of myself. I'm going to leave it at 5 because I can look on the picture and I can see where it's 5 at. So when is f of x 5? Up there. You guys are going to help me because mine's up there. 23. So it's f of 5. So f of x equals 5 at 23, right? So what are we moving it? Right 3. So that means that we're going to be right 3, 26. So 26 is the new solution spot. Okay. Good, good. It's a lot of Unit 2 stuff, huh? All right. Okay. So, consider the functions f of x, 2x minus 3, g of x, x minus 1, h of x, x plus 5. Determine graphically the solutions of the following equation to the nearest hundredth. Okay, so we're going to do the operation, and the movement and figure out the solution. So this is where it starts to get rational, right? Because if I'm doing a fraction here, I'm doing 2x minus 3 over x minus 1 minus 5 equals 0. And I'm solving for x now. Okay. So it says determine graphically. So you could do this graphically. I like to do it algebraically personally, but you guys can do it graphically, it's fine. Okay. So you'd actually just simply put, guys, you just put this right here into your y1. Make sure if you put this into your y1 that you have to have brackets around these, okay, especially the bottom. So I would put in like this. That's how I'd put it into your calculator for y1. Okay, actually, I put another bracket here for that minus sign too. Keep that separate. So yeah, I would double bracket mine. Okay, while you're doing that, just for fun for me, I'm going to solve here on the side algebraically. So if I can, I probably have to use quadratic formula, I think. Oh, no, I'm not. So if you're doing your calculator, you should get the 0.666 or 0.67. Solving algebraically, I got 2/3. Okay. Any questions? Okay, I'm going to get rid of this and do b now with you. All right, so b, square root f of x, so radical f of x is equal to g of h. Okay, so radical f of x, so square root 2x minus 3. Okay, and then I want to plug h into g. So that's going to be x plus 5, and for x, so it's going to be x plus 5 minus 1. So it's going to be x plus 4. Okay, this is a situation where you can go y1, y2, and use what feature? Intersect. Okay, so if you guys want to do that in your calculator, fine. I'm going to solve algebraically up here while you're doing that. Okay, again, this is just for fun. They didn't solve algebraically on the sheet here, but just doing it. Okay, so we get 2x minus 3 equals x squared plus 8x plus 16. Okay, they don't have to intersect though, if that's what you're saying. So I have 0 equals x squared plus 6x plus 19. Okay, so for me, at my point here, okay, you may have seen it already. It looks like they don't cross. Okay, it looks like it doesn't cross in yours. Okay, and that's actually correct. So there is no solution. That is the answer. Let's talk about it. In terms of the graph, you can see because they don't cross. That's the obvious statement. And in terms of algebraically, how can we determine that? Good, good, by quadratic formula, but even simpler, you can use a discriminant. You don't have to do the whole quadratic formula. And I use a discriminant because 19 is obviously a prime number. Only factors are 19 and 1. There's no way I can make that a 6, so I know I can't factor it. So then what I want to do is before I use quadratic formula, I want to see if there actually is solutions. Discriminant is simply this. It's only a piece of the quadratic formula. Okay, that's all the discriminant is. So it would be 36, 6 squared, minus, automatically, I know there's going to be no solutions. Check it out. 4 times 19 is bigger than 36. So I'm going to get a negative number. I'm not even going to calculate it. I just know it's going to be negative. When you get negative discriminant, that means no solution. Okay, back to what Aiden said, if you use quadratic formula, why does it mean that? Because when you're doing the quadratic formula, you square root this number. Can you square root negatives? No, that's where that comes from. Okay, that's where that comes from, the discriminant. Okay, good. We're going a little bit more detail on these we need to, but that's okay. We have time. It was short. All right, last one. 2 fraction ones here, so 2 rationals. Okay, so f of g, or f over g, excuse me. So f over g again, already did that one. So we have 2x minus 3 over x minus 1 equals x minus 1 over x plus 5. Okay. So you guys put those, y1, y2 again, do intersect, that's fine. For me, I'm going to cross multiply these. So by cross multiplying, I'm going to put the x minus 1 here, cancel it here. I'm going to put the x plus 5 and cancel it here. Okay, so that's going to give me, let's see what that gives me here, 2x squared, negative 3x, 10x. Okay, and then this side is going to be that. All right, so then if I subtract that stuff over, I get 1x squared, add, so 9x. X squared minus 9x minus 16. So it doesn't factor. So this is where I have to use quadratic formula if I'm solving algebraically. Okay. I will set that up just for the heck of it. So negative 9 plus or minus 81 minus 4 times 16 all over 2. So my calculation would be negative 9 plus or minus, let's see, 4 times 16, 40, 64, plus 64, 125? And so that would be your two calculations, I believe, if I'm doing my mental math right. Negative 9 plus or minus root 125 over 2. You guys should get, if you guys did it in your calculator in terms of the graph, the solutions are negative 10.52 and 1.52. Okay. All right, we'll stop there.